Hello class, today we are going to look at logarithms as inverses of exponents. Now in the previous video we saw that a logarithm is the inverse of an exponent. Now we're going to look at a more kind of focusing on that aspect of the logarithms. So first, since they are inverses, if you take the logarithm of base b of b to the x, you're taking the logarithm of an exponent. It's like taking the square root of a square. They cancel out. As long as the bases are the same, you're just left with this exponent as your answer. All right? And the same thing works if you have b raised to the power of log base b of x. Again, the bases of the exponent and the base of the logarithm are the same, and so it cancels out, just like a square root cancels out a square, and a cube cancels out a cube root. The bases are the same, so everything goes away. All right. Now, so let's take a look at A. We have 10 raised to the power of log of 4. Now, here you'll notice there is no base to the logarithm, right? But if there's no base, this is common log, which means it's base 10. So we have the base of our exponent is 10, and the base of the logarithm is 10, so that all just cancels out, and we end up with 4, just the argument of the logarithm. All right. Now on B, it's a little bit more complicated because the base of our logarithm is 5, but the base of the exponent is not 5. It's 25. But 25 can be written as an exponent with a base of 5, right? Because 25 is 5 squared. So we could write it like that, log base 5 of 5 squared to the x, right? Now we've got this, we've got to get rid of the parentheses, but that's not a big deal because an exponent raised to an exponent, you just multiply the exponents together, right? And so we have log base 5 of 5 to the 2x. And now we have a base of 5 and a base of 5, so it all cancels out, and we're just left with the 2x. All right? So that's not really too bad. All right, so here what we're going to do is we are going to write the inverses of the functions. All right. So f of x equals 6 to the x. All right. Well, this is an exponent. To write an exponent, the inverse of an exponent is a logarithm. So we're just going to write this as a logarithm. Instead of 6 to the x, we're going to have log base 6 of x. And this gives us the inverse, because by definition, the inverse of a logarithm is an exponent. All right. Now, B is, again, a little bit more complicated, not so much because it's got ln there, because remember, that's just log of the natural base, so log base e. What makes this a little bit more complicated is because we have x plus 3 in here as our argument there. But we're going to write this just the way we did other inverses for polynomial, exponential functions, and polynomial functions, and radical functions. All right. First, we're going to change this to a y. So it's y equals the natural log of x plus 3. And then we switch x and y. So we have x equals the natural log of y plus 3. Then we need to get y by itself. So what we're going to do is we're going to write our logarithm as an exponent. We're going to change this equation to exponential form. So the base of our logarithm, this is the natural base, so it's e. So we have e as our base. Our answer is x, so that's our exponent. So we have e to the x equals our argument of y plus 3. Got to get y by itself, so subtract 3 from both sides. We have e to the x minus 3 equals y. And we want to put this back in function notation. So we have the f inverse of x equals e to the x minus 3. All right. So a little bit strange, but not too bad. You're just going to take this, put this in exponential form, get y by itself. All right. Okay, so what I want you to do is solve these questions right here. All right, simplify the expressions, last two, find the inverses. So pause the video, work this out, and then come back and check your work. All right, let's see how you did. So number 13, the base of the exponent and the base of the logarithm are the same. They're both 8. And so they cancel out, and we're just left with x. Number 14, the base of the logarithm is the same as the base of the exponent. There's 7. And so those cancel out, and we're just left with negative 3x. 15, the base of the logarithm is 2, and the base of the exponent is not 2. So we're going to have to rewrite this 64 as some exponent with a base of 2. All right. So let's see, 64, that is 2 to the 6th. So we have log base 2 of 2 to the 6x power. And so base 2 cancels out, and we're just left with 6x. All right. 16, we have the base of the exponent is e, the base of the logarithm. We don't see one there, but it is ln. This is log of the natural base, so this is log base e. So again, the bases are the same, so they cancel out, and we're just left with 20. All right. 17, we need to find the inverse of f of x equals 4 to the x. Well, all we're going to do, since we don't have any addition or anything else going on in here, we can just rewrite this as a logarithm. So this is f inverse of x is log base 4 to the x, because there's no pluses or multiplication or anything going on in that. 18 takes a little bit more work, because we do have some stuff going on in our argument there. And so we're going to write this first as a y instead of f of x. And then we switch x and y. So we have x equals natural log of y minus 5. We write this as an exponent. Remember, natural log is base e. So we have e to the x equals y minus 5. Move the 5 to the other side. So we have e to the x plus 5. So f inverse of x is e to the x plus 5. And that takes care of that. Logarithms, remember, these are the inverse of exponents. If you have an exponent of a logarithm, the bases are the same, they cancel out. If you have the logarithm of an exponent, the bases are the same, they cancel out. And finding the inverse, just do that, and switch x and y and write it in exponential form. Or if you have an exponent, just like this was x plus 2, you want to take this and write it in logarithmic form. All right. All right. I hope you found that useful. I hope it helps, and I'll see you next time.